All right, in this video we're going to learn another way to depict stereochemistry called a Fischer projection. And the value of Fischer projections are these are what are used in a lot of biochemistry for carbohydrates in particular. And so this is something that usually students will be expected to know how to do coming out of organic chemistry. So if I take this molecule that I just drew, this is R-glyceraldehyde. And if we want to convert it into a Fischer projection, what we have to do is we have to have the most oxidized unit, so the CHO, which is an aldehyde at the top, and then we want the least oxidized one, this is CH2OH, down at the bottom. Okay, so we're going to rearrange this, and when we do that, we're going to sort of pull it out at you a little bit so that the OH and the H are coming up at you, and the CH2OH and the CHO are in the plane. So I'll show you what that means, or what that looks like. Okay, so I took the H and the OH here and pulled it up. And if you think about it, remember that the way I've drawn these, with the solid wedge here, the CHO is coming straight out at you, and the CH2OH is going straight back. So if I pull these two up, then these two end up shifting towards the back. So I've got something that looks sort of like this, where with the CHO and the CH2OH going back, the OH and the H coming out at you. And it's still a tetrahedron. Now to convert that into a Fischer projection, all I do is I get rid of the wedges. And so at the bottom I have CH2OH, at the top I have CHO, to the right I have OH, and to the left I have H. This is now a Fischer projection of glyceraldehyde, and of R-glyceraldehyde. All right, so that's a Fischer projection now of R-glyceraldehyde. Now you can do the same thing with S-glyceraldehyde if you want to in practice. So why don't you try that, and then I will draw it. Okay, there I just drew S-glyceraldehyde. So if you look at it, it's just the reverse of up here, where the H and OH, the hydrogen's on the left, the OH on the right, now they're switched. Now if I convert that into a Fischer projection, try and do that if you couldn't already. I'll pause while you do that. All right, and here's the answer, so hopefully you got it right. So now this one is S-glyceraldehyde. So now I have R-glyceraldehyde up here, and this one's S-glyceraldehyde. Now I'll also go through how to figure out whether or not, whether our Fischer projections are R or S. Okay, so if you're going to figure out R and S, you have to do the same thing you would always do, and that is figure out your priorities. So if I'm going to look at this left one, bromine would be 1, hydrogen would be 4. I've got carbon and carbon, which are both the same. Keep going to the next atom. Here I have oxygen, here I have hydrogen, so this one is 2, and this one is 3. Now, you have to look and see, is your hydrogen going up or down on the Fischer projection first? Because if your hydrogen is going up or down on the Fischer projection, that's the equivalent of it being back or behind the plane. And that way, you can follow the normal R and S rules. Connect 1 to 2 to 3, 1, 2, 2, 2, 3, and if it's clockwise, it's R, and if it's counterclockwise, it's S. Okay, so in this case, I've got 1 to 2 to 3. My 4 group is going up and down. That means it's behind the plane. So that means that I can follow this, and that's just what it looks like. 1 to 2 to 3 is clockwise, so this would be R. However, in this situation, my 4 group is going left or right. So I've got 1 is chlorine, 2 is CHO, 3 is CH3. My 4 group is going left or right, which means it's coming up at you. Okay? So if you remember from previous R and S things, if the hydrogen is coming out instead of going back, it's going to be the opposite of what it looks like. Opposite of how it looks. So here now, you can still do the same thing, and you can still say, okay, I'm going to connect 1 to 2 to 3, right? Ignoring 4, connect 1 to 2 to 3. It looks clockwise, but it's going to be S, because it's the opposite of how it looks. So this molecule would have S stereochemistry. The first one would have, over here, would be R stereochemistry. This one here is S stereochemistry. That's the easiest way to go through and figure out the stereochemistry in a Fischer projection without having to try to redraw or maneuver the molecule around. Right, there's one more piece that's interesting to look at in monosaccharides, and in Fischer projections in particular, is whether sugars are D or L. And D and L is an older term. And what the D and L have to do with is they have to do with where the groups are on the stereocenter farthest from the most oxidized group. And so here's our carbonyl group, or our most oxidized group. There is only one stereocenter here. So we're going to look at the stereocenter farthest, which is this one. Okay? And in this case, if the OH group of the sugar is to the right, that makes it a D sugar. OH to the right. So you redraw it and draw what would be the L sugar, or the one with the OH group to the left. Okay, so pause the video for a second and try and draw that, and then come back and I'll draw it for you. All right, so there's the L sugar, or L-glyceraldehyde. So this one on the left now is called D-glyceraldehyde, and the one on the right is L-glyceraldehyde. D-glyceraldehyde is what we did on the last one. It's also can be called R-glyceraldehyde. But when you get into sugars, people don't usually use R and S. They'll use D and L instead. So that's another way that we can name our materials. And as you get into more complex carbohydrates, you'll start to see even more examples of this. But no matter what sugar you're working with, there's always going to be a D and L version that you can draw.